Let me fix number 3 here. There are some answers. Feel free, check those out. We can discuss. When you're ready.
How'd you get this? Two x squared plus 14x.
That's fine? Okay.
Yep. I kind of prefer that way because if something is going to end up simplifying in the end, you'll be able to see these here. But no problem. That's not something that I can just answer in a real simple.
Yeah.
You're right on the edge.
I think it's age.
You see the common 3? So factor 3 and 3 is what's 24. If you get that GCF out of there, I think it'll be.
You went from subtracting 50 to somehow the 40 was just magically on the other side.
Mr. Anderson, can you do the 5?
Yeah. Yep. Yep. Be happy to. Yeah, so we don't have a unit set for 7.
Well, that's just because I multiplied. So that's nice.
We don't have our test, right?
We have it tomorrow.
No, it's okay. It's not okay, that was really I thought so too, but I had to make sure.
4 hours.
Okay, you guys, listen up. I'm going to go in order here for a reason. Had a couple folks talk about number 4, and I'd be happy to show you that one, but I'm going to do that at the end. So I'm going to go in order here. Does anybody want to talk about, discuss, see, whatever with number 1? Anybody want to do anything with number 1? Joe? Okay, so number 1, it says, write the equation in slope-intercept form. And so I know that slope-intercept form, and I hope you know the same thing, that slope-intercept form is y equals mx plus b, where m stands for slope and b stands for the y-intercept. And so what I'm going to do is I'm going to directly use the graph. You could get some points off the graph and do some calculating if you wanted to. What I'm going to do is I'm going to notice that this point right here is on the graph of the line, and that point right there is on the graph of the line, at least it appears so. Listen up, please. So then if I'm going to find my slope, remember that slope is simply rise over run, or rise divided by run. So I'm going to say that this distance right here is my rise, and technically it's going down 2, so I'm going to say the rise is -2, and it's going to run all the way over here to this point. That's a distance of 6. So the rise is -2 because it's going down 2, going right 6. So I'd say my slope is -2 over 6, which will, of course, reduce down to -1/3, like you saw. And then my y-intercept is going to be the place where my line crosses the y-axis. That appears to be right there. And again, you got a graph, so we're not going to split hairs and say, oh my gosh, Joe, it looks like it's 2.1. We're just going to say it's 2. Like, to the best of our powers of observation, we'd say it's 2. So that goes in place of the b, and I got it. That make sense? Okay. All right. Anybody want to discuss number 2? A ship. A shop. Okay? Yeah, for sure. Okay. So listen, as you guys know here, I am a big fan of helping you to be a problem solver. And there's graphic organizers. There's all these different ways of getting your data organized, but I think that none of that really matters if you don't understand what's actually happening, right? So in order to understand what's actually happening, we need to use some reading comprehension skills and try to discern that. So a cruise ship left Seattle, and it headed towards Alaska. So this is going to be this cruise ship. I'm just going to say it goes this way, like so. So I'm just reading this, right? I'm just getting my ideas down on paper. And then I realize, whoa, okay, hold on. A second ship left 4 hours later. Now, wait a minute. Isn't this one of those scenarios where the first ship gets a big head start? Okay, so I'm going to go back and I'm going to say, I don't like that anymore. I'm going to go back and say the first ship got a head start and the second ship didn't. So the second ship actually started back here in Seattle. And the first ship did too, but the first ship got the big head start, right? So this dotted line on the left, this represents Seattle. And somewhere out there in the ocean, supposedly the purple ship is going to catch up to the black ship. Perhaps. That make sense? Okay, so I'm going to call this one, I'm going to call this like distance 1 for the first ship. I'm going to call this distance 2 for the second ship. Again, not particularly creative, but hey guys, you're being a distraction. Could you stop? Please? Thank you. Okay, so then in order to be able to figure out what I need to do here, I need to figure out how big of a head start exactly the black ship got. So the black ship is going 10 kilometers per hour, and for how many hours did it get a head start? So how many miles of a head start then? 40, right? Distance equals rate times time. So I'm going to say this distance here is 40 miles. Okay, so you were supposed to be able to do this just by reading it, and this is reading comprehension, right? So if you think about it, the only math I've done, as I said, 4 times 10 is 40. So for you guys, hardly a big stretch, right? Not a difficult thing to do. So all I've really done is try to do reading comprehension. I'm not going to get into any complicated math yet. We'll do that here in a second. But for right now, it's just take the wordings and try to get a picture on your paper. Now here's the more complicated, the more challenging part. What we need to do is we need to look at our picture, look at all the information we have in our picture. We need to say, how do I relate this stuff in a way that's true? So let me give you an example of something that's not true. I could say this. This is really common. Sometimes people will just jump to this. Does distance 1 equal distance 2? No. Because clearly the black boat got a head start. They're clearly not equal to each other. So I can't do this. Can't do that. That's just not true. So I need to write something that is true. Anybody know? Like, what could I do with all those distances and numbers and symbols that actually is true? There you go. D1 plus 40, the short distance plus the head start, equals the longer distance. So we're just looking to write down a relationship that's actually true, not something that's made up or blatantly false. Okay, so then the way we finish this is we realize that distance equals rate times time. So the rate of the first boat was 10. So I'm going to say 10t, right? Rate times time is distance. So 10t plus 40 is equal to d2. The rate of the second boat was 15. So the distance would be 15t. At this point, I've got a fairly lovely equation which I can solve pretty quickly. Subtracting 10t from both sides gets me to 40 equals 5t. If I divide both sides by 5, I get t equals 8 hours, which would be the time that it would take for their overall position to be the same, therefore the purple boat catching up to the black boat. Somewhere in there you figured it out, I can see. Others, follow-ups on number 2? Okay, number 3 then. Number 3, as you probably noticed, this is essentially your concept quiz. Number 3. Yes, ma'am.
So, what if we distribute it? Because I have 2x squared.
Sure. So 35 over 2x squared plus 14x?
Yeah.
100% correct. I personally prefer the factored form because if something is going to simplify, you'll be able to see it pretty easily. What you wrote is fine. 100%. Three? Okay, so if you are, so this is, I'm still like doing some self-reflecting. I don't know where I led you wrong or what the deal is, but we have this aversion to factoring out the GCF. Right? As I walked around, like that was the number one thing I saw and said was factor the GCF, factor the GCF. We want to jump right into those boxes, and I get it. The boxes are it's kind of a nice little graphic. It helps you. But before you do any kind of factoring at all, factor the GCF first. Okay? So I look here and I think, oh, I'm subtracting fractions. So in order to subtract fractions, I need to have a common denominator, and they're clearly not a common denominator. And so I could take a couple of tactics here, but really the best way to get the lowest common denominator is to understand the factors of the denominators. So step one would be to factor each of the denominators. 2x is just 2 times x. That's already factored. We already have the prime factors there. But the other one is not. And if you're going to factor, if you're going to take something that is not multiplication and turn it into multiplication, you're going to have to factor. And if you're going to do that, you have to factor the GCF first. You have to do that. So don't skip that step. Because when you look at that second denominator, what's in common?
7 and 2.
Not a 7. Oh, you're thinking about what's left over.
Yeah.
I'm just talking about what can you take out.
2.
2x, yep. So there's a 2x in common, and then the leftovers would be x plus 7. And once you do this, you realize there's no more factoring to be done. And this is so common, where you factor out the GCF, and you look at it and you're like, whoa, I guess I'm done. Versus doing all this stuff with boxes and making a big mess and not ever really getting it correct. If you had just factored out the GCF, you might have looked at it and said, oh, that's all? Done. And that's the case here. So then, Colton, can you see now how the left fraction is just missing a factor?
Yeah.
What do I need to multiply the left fraction by?
X plus 7.
That's right. So if I multiply by x plus 7, both denominator and numerator, I'll be in pretty good shape. So when I do this, I get 5x plus 35 over that common denominator minus 5x over that common denominator. And when you actually are adding or subtracting fractions, what do you actually end up doing with the denominators? Say again? Leave them the same. Yeah, there you go. When you are actually subtracting or adding fractions, once you do have that common denominator, the denominator just remains as is. So it would be 2x times x plus 7 for my denominator. And 5x plus 35 minus 5x, wouldn't the 5x be the like terms? 5x minus 5x is 0. You're left with 35. Okay. Questions? No? Okay. All right, so I want to leave number 4 for the end because I got to be honest with you and say number 4 is like barely review. And for those that didn't watch my We Didn't Have School Wednesday video, it's not review at all. So again, let me just remind you this, and hey guys, and this is so huge. This is a really important like maturity level thing here. When and this would hopefully serve you well as you move into like your sophomore and junior and so on and so forth. Like when we have a snow day, when we have some like weird day like we did on Wednesday, you can't look at it and say, oh cool, school ceased to exist for a day. Well, I guess, well no, I take that back. You can choose to do that, but you better be willing to live with the consequences. Does that make sense? You better be willing to live with the fact that now you're behind. But you could always go back and rewatch the video, I suppose. So here's the deal with number 4. This will segue nicely into the little bit we're going to do here today. So pay really close attention, because for some of you, this was not review at all. Okay? The first thing I would think about here is we are dividing fractions. And when you are dividing fractions, the first thing you'd want to do is you want to think copy.flop, right? So if I copy.flop this, I get 3x plus 24 over 5x. There's my copy. Here's my dot. That's turning the division into a multiplication. Flop, this means I find the reciprocal of that second fraction, and I get to here. So, if I'm going to be multiplying these together, I want to think about this. I'm going to be trying to reduce this at some point, right? And I think most of you have arrived at the idea that reducing ahead of time is a whole lot easier than reducing at the end.
Yes.
But in order to be able to accurately and correctly reduce ahead of time, you must have factors. You must have factors. And right now up there, I only see a couple of factors. I would say that 5x has been factored, right? It's literally just 5 times x. Same thing, 5 times x. Those two elements are factored. But do you see how the other two elements are not?
Yeah.
3x plus 24, that's addition.
Yeah.
X squared plus 7x minus 8, that's addition and subtraction. Those are not factored. And so in order for me to be able to simplify ahead of time, I need to be able to take something that is not in factored form and put it in factored form. So I'll leave the 5x as is and the other 5x as is. I'm going to try to factor the other two expressions. The upper left, whenever you're factoring, you always do a GCF first. Never ignore that step. What's in common in the upper left?
3.
3. Okay, so 3 parentheses x plus 8. When you look at this, you realize, whoa, that's all I had to do. There's no more factoring possible, at least not with real numbers. Lower right. What's the GCF for the lower right? There isn't one. So then we think to ourselves, oh, well, could it factor a different way? Right? We always check GCF first. Whether there is or isn't a GCF, we always think, well, could I do something different? Maybe the boxes, right? This is a quadratic, and you would find if you did the boxes that this does factor as x plus 8 times x minus 1. Now that everything is in factored form, this is when you can do some cross or vertical simplification. So does anybody see something that would divide out?
Yes.
What do you see?
X plus 8.
X plus 8 divides out with x plus 8. Agreed. What else? The 5 and the 5 and the x and the x. Those would divide out as well. At this point, I look at it and think, well, I think I'm done with that. The numerator is 3 times 1. The denominator is x minus 1. Nothing else is going to be canceling there, right? Done. So the key to being able to simplify these and multiply and or divide, like we just did here, is you must have factors. If you don't have factors, stop canceling, right? If you have factors, then maybe you can go through and carefully cancel. But I would say canceling is the most misused, overused, incorrectly used thing I've ever seen in math. People just want to cancel everything and really even know what it is. Remember, it's just division. Yeah, Joe.
So that applies to every different type of these type of problems, right? Like
If it's-
addition, subtraction, division, and multiplication.
So the addition and subtraction, yeah, that can get really tricky because people start to see things that aren't there or not see things that are there. So if you're adding and subtracting fractions, and I told you this when we were doing that, you need to be like extremely cautious because you're going to want to just start canceling stuff out. And I would say the canceling of things out within addition and subtraction is very rare. It's possible, but it's extremely rare. And it would very likely happen at the very, very end. Whereas when you're multiplying or dividing, all the canceling that could be done can realistically be done at the start. So really it comes down to differentiating between, is this addition or subtraction because I need to hold off on any canceling till the end? Or is this multiplication or division because I probably should be doing all the simplifying at the start?
Yeah.
And where people go wrong is they'll treat addition like it's multiplication.
Right.
And it's not. They're just different. So so I'd be, like when I'm thinking about your concept quiz coming up here in a second, I would be like hyper careful to not do any canceling at all until maybe the very end, possibly. But even then, it may or may not happen at all.
Right.
Whereas with this multiplication division thing, it can happen a fair amount. Okay. Any other questions? All right, so let's do this. Let's do your concept quiz. This hopefully was a really good warm-up for you. Grab a divider from back there or over there if you need one. We'll get started. Yes, ma'am. Of course. Okay, for those still working on their concept quizzes, just continue to process through there. Hopefully they'll go by quickly for you. You can start on these two. Whose brother? Your grandma's brother. Got it. Your parents' uncle. Your dad's and mom's uncle. Yeah, you don't think about some of those things before we do.
Yeah, that's like.
Yep. No, so this is that one, there's always that one quiz that, leads over in the next unit, so that's what this is, so any retries you guys. Yeah. 18 people. Yeah, that's all, just like these. This one. Chief. Okay. Working on 1 and 2, please. What do y'all think about number 1?
It's alright.
X
I did it in 2 steps.
Okay.
Did y'all notice with number 1 it was already factored? Everything was already a multiplication. You didn't have to do any extra work to factor.
That's what.
You know what it is here? You know what caused you a little challenge with number 1 is when you distributed. Now it's hard to see the factors that would cancel. This is like if you have x to the 7th 4 times, like everything's factored, right? X to the 7 over x to the 2, that's x to the 5th, right? Right? So when you simplify this, you're going to want to like find everything that simplifies. And you did some of it for sure, but there was more. There's for sure.
4x to the 5th.
Just like this.
Oh, that's where I was.
That make sense?
Yeah.
I still don't know where.
Guys, questions on number 1? Questions on 1?
The same game. Do you know Tyree? It was really fun.
Okay. Showing you an answer to number 2 here in a second.
I think my brother's I just forget it there.
I was playing Halo when I was like 6.
Oh, I put X. Oh no, I got it. Yeah, I put just X.
How about number 2?
Oh my gosh, I got it. Okay, I got it right.
Yay. That's great. Tomorrow is review day. Bring the materials that you'll need. Have a great day.